In the early summer of 2026, a claim started spreading across space channels and social feeds that sounded almost too perfect to be true. Voyager 1, the farthest human-made object ever launched. A probe that left Earth in 1977 and has been drifting through interstellar space for over a decade, had somehow found Planet 9. And not just found it, confirmed it. With Hubble. With James Webb. The headlines made it sound like the 9th planet, hunted for a decade, chased through mathematics and shadows and half-glimpsed infrared smudges, had finally been caught, and that a 48-year-old spacecraft built before the personal computer existed had somehow been part of catching it. It's a great story. The problem is figuring out how much of it is actually true. So let's do this properly. Let's separate what Voyager 1 can and can't do, what Hubble and Webb have actually been looking at, and what the real, still unfolding hunt for Planet 9 has genuinely found. Because the real version of this story doesn't need exaggeration. It's strange enough on its own, because underneath the exaggerated headline sits something astronomers have been chasing seriously for a decade. The possibility that our solar system has one more planet in it than anyone alive has ever seen, hidden not by distance alone, but by a kind of darkness that makes it almost invisible to every method we've traditionally used to find planets. That's the real mystery, and it deserves to be told without a 48-year-old spacecraft getting credit for something it structurally cannot do. Here's where we have to start, because it changes everything about how you should read that headline. Voyager 1 cannot see planets. Not anymore, and honestly, not even when it was closer to home. Voyager 1 carried a camera system once, and NASA turned it off in 1990, right after it captured the famous pale blue dot image of Earth from nearly 4 billion miles away. The spacecraft has spent the 36 years since then running on a handful of surviving instruments designed to measure magnetic fields, charged particles, and plasma waves in the thin, cold material of interstellar space, the environment just outside the sun's protective bubble. It has no telescope, no imaging optics, no way to photograph anything, let alone a planet that might be hundreds of times farther from the sun than Earth is. So when a headline says, Voyager 1 found Planet 9, the honest answer is that it's not describing anything the spacecraft is physically capable of doing. Voyager 1 is currently more than 25 billion kilometers from Earth, moving through interstellar space, sending back a trickle of data at a rate slower than an old dial-up modem, using instruments built to sense particles, not to take pictures. Whatever Planet 9 is, it wasn't Voyager's cameras that found it, because those cameras have been dark for over 3 decades. Think about what that distance actually means. A radio signal from Voyager 1, traveling at the speed of light, currently takes over 23 hours to reach Earth. By the time mission controllers receive a status update, the spacecraft has already been doing something else for nearly a full day. That's not a probe casually snapping a photo of a hidden planet and beaming it home. That's a machine on the very edge of human reach, running on a power source that loses wattage every year, built in an era when the most advanced onboard computer had less processing power than a modern kitchen appliance. Whatever finds Planet 9, if anything does, it's going to be something built decades later, with instruments Voyager's engineers in the 1970s couldn't have imagined. That doesn't mean the rest of the story is empty. It means the real story is happening somewhere else entirely. And it's worth telling properly. Planet 9, as an idea, goes back to 2016 when Caltech astronomers Konstantin Batygin and Michael Brown noticed something odd about a small cluster of distant icy objects beyond Neptune. Their orbits were clustered together in a way that shouldn't happen randomly, tilted at similar angles, aligned in similar directions, as if something massive and unseen were gently herding them into formation. Their proposed explanation was a hidden planet, several times the mass of Earth, orbiting far beyond Neptune, its gravity quietly organizing the outer solar system without anyone ever having seen it directly. Brown, notably, is the same astronomer whose earlier work helped demote Pluto from full planetary status back in 2006, a scientist with a track record of redrawing the map of the outer solar system, rather than simply speculating about it. That history is part of why the Planet 9 hypothesis was taken seriously from the start, rather than dismissed as another in a long line of hypothetical Planet X claims that stretch back over a century, most of which quietly faded once better data ruled them out. For nearly a decade, that's exactly what Planet 9 has remained, a gravitational signature without a face. Astronomers have hunted for it using every method available. Visible light surveys looking for reflected sunlight, which is nearly hopeless at that distance because the planet would be almost impossibly faint, and infrared surveys looking for the planet's own residual heat instead, since even a cold, distant world slowly radiates warmth left over from its formation. To understand why this search is so difficult, picture trying to spot a single dim ember from a campfire that went out years ago, from miles away, at night, while the wind keeps shifting ash across your view. Reflected sunlight is what makes nearby planets easy to photograph. Jupiter, Saturn, even distant Neptune all shine because sunlight bounces off their clouds and back toward Earth. But sunlight fades with the square of distance twice over, once on the way out to the planet and once on the way back. At the distances proposed for Planet 9, hundreds of times farther from the Sun than Earth, reflected light becomes almost non-existent. That's why astronomers switched strategies entirely, hunting instead for the planet's own faint body heat, radiating in infrared wavelengths invisible to the naked eye but detectable by the right instruments. A much fainter signal, but one that doesn't depend on borrowed sunlight to exist. That second approach is where the real evidence, the evidence people are now garbling into the Voyager headline, actually comes from. In 2025, a research team led by astronomer Terry Long-Fan took a clever approach. Rather than searching for new images, they went back through archival data from two infrared satellites, Japan's Akari mission and an older American satellite called IRAS, whose sky surveys were taken 23 years apart. If Planet 9 exists and is moving slowly enough at that extreme distance, it should appear as a faint dot in one survey and have shifted slightly by the time of the other. The same object caught twice in two different positions, its motion revealing itself over more than 2 decades rather than in a single snapshot. They found a candidate, a faint infrared source that showed up in the right kind of position in both datasets, with brightness and motion broadly consistent with a planet more massive than Neptune, sitting somewhere between roughly 280 and 1100 astronomical units from the Sun, a distance so extreme that light from the Sun itself would take days to reach it. That's genuinely exciting. It's also, by the researchers' own admission, nowhere near confirmed. Here's the honest complication, the part that separates careful science from a viral headline. The candidate's orbit doesn't fit cleanly. Models built by Badigian and Brown predict that Planet 9, if real, should have an orbital tilt of somewhere around 15 to 20 degrees relative to the plane of the solar system. The new candidate's orbit appears tilted by roughly 120 degrees, wildly different from what the original theory expected. Mike Brown himself, one of the two astronomers who first proposed Planet 9, has publicly noted that this mismatch doesn't rule the candidate out, but it does mean it doesn't neatly match the planet his own model predicted. Either the object is something else entirely, or the real Planet 9 is stranger than the original theory imagined. And then, just to complicate things further, a completely separate discovery muddied the water even more. In the summer of 2026, astronomers using the Subaru telescope in Hawaii found a small, distant object, nicknamed Ammonite, technically called 2023 KQ-14, orbiting out in the same general region of the solar system Planet 9 is supposed to influence. Ammonite's orbit doesn't line up neatly with the clustering pattern that originally inspired the Planet 9 hypothesis. If anything, its existence weakens part of the original evidence, because it's exactly the kind of object that should have been shepherded into alignment by a massive hidden planet, and it isn't. So where does that leave things, honestly? Not confirmed, not disproven, genuinely, uncomfortably in between, which, if you've been paying attention to how real science actually works, is usually the most interesting place for a mystery to sit. Let's pause here and take stock, because it's easy to lose the thread in all the caveats. What's real? A decade-old gravitational puzzle involving clustered orbits beyond Neptune. What's real? A specific infrared candidate, independently spotted in 2 historical satellite surveys separated by 23 years. What's disputed? Whether that candidate's orbit actually matches what the original theory predicted. What's false? The idea that Voyager 1, or any joint Hubble Webb announcement, has settled any of it. Hold that shape in your head, because the next question is the one that actually matters. Not has it been found, but how would we ever know for sure? Now, what about Hubble and Webb? Because that part of the claim isn't a pure fabrication either. It's a distortion of something real. Neither Hubble nor James Webb has announced a confirmed detection of Planet 9. That hasn't happened, and no credible astronomer working on this problem is currently claiming that it has. What is true is that both telescopes are part of the broader toolkit astronomers are counting on to eventually settle the question, because once a strong enough candidate position is identified, through infrared archival work, gravitational modeling, or the newest and most promising tool in the search, powerful telescopes like Hubble and Webb are exactly what would be used to point at that spot and check. And that newest tool is arguably the real headline hiding underneath the fake one. In 2025, the Vera C. Rubin Observatory in Chile achieved first light and began full survey operations. Rubin is built to do something no previous telescope has managed: photograph the entire visible sky over and over every few nights for years, building a moving picture of the solar system rather than a single still frame. If Planet 9 is out there, drifting slowly against the background stars, Rubin is designed to be the instrument that Final Y catches it moving. Not through a single infrared shadow 23 years apart, but through a continuous stream of observations sensitive enough to pick out a faint, slow-moving object that every previous survey may have missed. Astronomers researching this question have specifically pointed to Rubin's observations, now actively underway, as the most direct test the Planet 9 hypothesis has ever faced. To understand why Rubin changes the equation, compare it to everything that came before. IRIS mapped the sky once in the early 1980s. Akari mapped it again more than 2 decades later. Between those two snapshots, astronomers had to guess at everything that happened in the gap. Hoping a single object's motion, captured only twice, was enough to prove it was real and not a coincidence, a cosmic ray hit, or an unrelated background source that happened to line up. Rubin doesn't work that way. Its wide-field camera is scheduled to revisit the same patches of sky repeatedly over its 10-year survey, stacking image after image until anything that moves against the fixed backdrop of distant stars becomes almost impossible to hide. A planet creeping along its slow, multi-thousand-year orbit would leave a trail across dozens or hundreds of images, rather than just 2. The difference between spotting a single footprint in the sand and watching the entire set of footsteps that made it. That's the real headline hiding underneath the fake one. Not a decades-old spacecraft closing the case, but a brand new observatory finally equipped to run the search properly, from the ground up, for the first time in this hypothesis's 10-year history. That's the real state of the search, as of right now. One disputed infrared candidate with a tilt that doesn't fit the original model, one new discovery that complicates the underlying evidence, and one enormous new observatory finally positioned to give a real answer within the next few years. Not a confirmed discovery, credited to a decades-old interstellar probe with no cameras. A live, unresolved, genuinely thrilling scientific hunt that doesn't need embellishment to be worth watching. It's worth sitting with why any of this matters beyond the satisfaction of solving a scavenger hunt. If Planet 9 turns out to be real, it wouldn't just add a new dot to solar system diagrams. It would mean our home planetary system builds massive Neptune-sized worlds in its far outskirts more easily than anyone assumed, quietly reopening questions about how the solar system's outer regions formed in the first place, and why a planet that big could have gone unnoticed for so long. It would also mean the strange clustering of icy objects beyond Neptune, the pattern that started this whole hunt back in 2016, has a physical explanation instead of remaining an unexplained coincidence. And if it turns out not to be real, if Rubin's years of continuous sky scanning eventually rule out anything matching the predicted mass and orbit, that would be just as significant. It would mean the clustering of those icy bodies has some other cause entirely, something astronomers haven't fully worked out yet, whether that's an unseen population of smaller objects acting together, a statistical fluke in a limited sample, or gravitational effects from something that formed and then left the solar system entirely billions of years ago. Either answer rewrites part of the story of how our own solar system came to look the way it does. There's no version of this ending that leaves the textbooks unchanged. So why does the Voyager version of the story spread anyway? Partly because it's a better headline than the truth. A forgotten 40-year-old spacecraft accidentally proves a hidden planet is real hits differently than an infrared archival comparison found a candidate whose orbit doesn't quite match predictions. One is a clean, satisfying twist. The other is what actual research looks like, promising, messy, and still open. But there's also something almost poetic about why people want to believe the Voyager version, even though it isn't accurate. Voyager 1 really did leave the solar system's inner neighborhood decades ago. It really is out past the influence of the planets we can see, drifting through the exact region of space where a hidden ninth planet's gravity would, in theory, be doing its quiet work. The spacecraft's location makes it feel like the right storyteller for this particular mystery, even though its actual instruments have nothing to do with the search. It's a case where the symbolism lines up perfectly, and the science simply doesn't follow. There's also a simpler explanation, one that applies to a lot of viral space claims. Uncertainty doesn't travel well online. A careful paper describing a 40% chance of a genuine detection, pending years of follow-up, doesn't summarize easily into a punchy title. Possible candidate, orbit doesn't quite fit, massive follow-up still needed, turns into confirmed somewhere between the press release and the fifth retelling, and by the time it reaches a headline, the qualifiers have quietly disappeared, and a spacecraft that happens to be in roughly the right part of the sky gets pulled in to make the story feel complete. If you strip the myth away, the honest version is arguably more impressive than the fake one. Astronomers found this candidate not by pointing a brand new telescope at a clean patch of sky, but by digging back through data that had already been sitting in archives for decades, comparing two surveys taken 23 years apart, looking for a single faint point of light that moved just enough to betray itself. That's detective work, not luck. It's patient, careful, and entirely earned. And it still isn't finished. Here's where the evidence genuinely stands, laid out plainly. Established. The orbital clustering of distant icy bodies beyond. Neptune, first identified by Badigan and Brown in 2016, remains a real and still largely unexplained pattern. Established. A specific infrared candidate, spotted independently in 2 historical satellite surveys 23 years apart, is currently the strongest direct observational hint anyone has produced. Disputed whether that candidate's orbital tilt is compatible with the original theoretical prediction, a mismatch that has drawn public skepticism even from one of Planet Nine's original proposers. Unknown whether Rubin Observatory's ongoing survey, now actively collecting data, will confirm the candidate, rule it out, or find something else entirely hiding in the outer dark. And confirmed false, plainly, that Voyager 1 detected anything, that Hubble and James Webb have jointly announced proof of Planet Nine's existence, those specific claims don't match what any of the researchers involved have published or said. So here's the actual reveal, and it's not the one the viral headline promised. Planet 9 has not been found. What has been found is something arguably more interesting. A genuine, unresolved scientific puzzle with real data, real disagreement among the experts who proposed the idea in the first place, and a brand new observatory now specifically built to settle it, one way or the other, within the coming years. The 48-year-old spacecraft drifting through interstellar darkness isn't the instrument that will answer this question, but somewhere out past Neptune in the region its trajectory happens to pass near, something massive may genuinely be hiding. And for the first time, astronomers have a tool sensitive enough and patient enough to actually go looking, night after night, until it either shows itself or proves, once and for all, that it was never there. Which means the real cliffhanger isn't a headline that already happened. It's a question that's still open, being tested in real time, with an answer that could arrive within the next few years rather than the next few decades. If Rubin Observatory does finally catch it moving across the sky, do you think it'll match the tidy, well-behaved planet Badagen and Brown originally predicted? Or something stranger, tilted and off-pattern, like the disputed candidate hinted at? Drop your guess before the real answer comes in, because unlike the Voyager story, this one hasn't been decided yet.